So we have secured our function app endpoint by requiring a token with a certain audience value. The thing that gets that token for us when calling the function app from the logic app is the logic app's managed identity. And that seems to work great. But that also means that we run into a potential problem, for example, during development. The endpoints can no longer be accessed without providing a valid token. In the Azure environment, the managed identity is responsible for getting and passing to such a token, but as you know, managed identities are an Azure-only thing. You cannot use a managed identity locally for testing. This, by the way, doesn't just apply to functions. It also applies to endpoints you have elsewhere defined, like in an app service, via a logic app, and so on. Anywhere, really. Let me, for example, try and send a request to a function app endpoint from my local machine here. So let's first get the function app endpoint. This is the base domain. Let me copy that. Let's set that as host address root. There we go. And getting the itineraries was one of the functions we have defined. So let me send this request here. Invalid URI. Did I forget something? Of course. HTTPS. Without the scheme, this won't work. And let's send that request again. And we get back a 401 unauthorized as expected. So how do we re-enable access then? Well, there's actually quite a few ways to do that, but one of the more convenient ones, which I do want to show you because you can use it across services, and I tend to use it quite a lot during development, is via the Azure CLI. There's a command, az account get access token. That command was specifically created to get access tokens for utilities, like the ones you use during testing or development to get an access token. I've opened PowerShell and I've previously logged in using AZ login. So I'm now going to execute that command, az account get access token. And I also pass through a value for resource. What I pass through here is HTTPS management.azure.com. That is the audience that we expect to be in the token. As you remember that level of the function app, this is what we defined as a valid audience. And here's our access token. Let me copy that. And let's set that as a bearer token when calling the itineraries endpoint at level of our function. So I'm going to pass through an authorization header, bearer, followed by the token. All right, let's send this request. And we still don't have access, but something has changed. We get back a 403 forbidden instead of a 401 unauthorized. A 401 essentially means, hey, I don't know who you are, you can't come in. A 403 means, hey, I know who you are, but you still can't come in. So we need to figure out why. Well, the reason is that we were pretty strict when we set up the security requirements for our function. Let's go back to that. So I'm going to open the authentication tab here again at the level of the function. Let's choose to edit. So we've been pretty strict when we set up the security. What we see here is that we only allow requests from specific client applications. The one we allow is currently only our logic app. We also only allow requests from specific identities. And the one we allow is the managed identity of the logic app. This is strict. Like this, the token will never give access. What do we need to do? Well, first of all, we need to ensure that the client application that requested our token is allowed access. What is that client application? Well, that is the Azure CLI. Microsoft's client applications all have fixed application IDs. You can find them via the link on screen. This comes in very handy when you work in security, by the way. The Azure CLI is one of those. So you can find that on this link. But the other place where you can find that identifier is in the token itself. So the identifier of Azure CLI is in the token. I've opened jwt.io a site which you can use to view the contents of a token, and I pasted in my token. The app ID claim here, that is the one that contains the identifier of Azure CLI, as that is the client app that requested the token. So I'm going to copy that, and I'm going to add that to the allowed client applications list. All right, that's one. Up next, the allowed identity. I did not fetch a token with the managed identity of the Logic app in this case. I fetched the token through the Azure CLI with the account I used to log into the Azure CLI. In other words, with my own account. So I need to add myself as one of the allowed identities. You can find that via Entra ID by simply looking for yourself, but you can also find that in the token, of course. The OID claim, that is the one that contains the identifier. You can actually see that here, my name and my identifier. So I'm going to copy this, and I'm going to add that to the list of allowed identities. All right, let's save this. And it could be that you now need to wait a minute, maybe 2 minutes for this to have an effect. So I've waited a bit. Let's send that request with that token again. And there we go. The token now allows access. So far, so good. And with that, we have successfully created a secure Logic app that integrates with Office 365 for sending mail and also securely integrates with one of our function apps. But we could have probably built this with a durable function as well, right? So why choose a Logic app, or why choose a durable function? Let's investigate. So in the last section, we learned about Azure Functions, a serverless compute service, and in this one about Azure Logic App, a serverless platform for integrations and workflows. If you look at what's possible with the Durable Functions extension for Azure Functions and what you can do with Logic Apps, you will quickly notice a bunch of overlap, as both are designed to enable complex orchestrations. Essentially, a collection of functions in Azure Functions lingo or actions in Logic App lingo. Sending a mail, calling a function, having a request for leave approved by a bunch of people, processing payroll data by integrating with a set of systems over HTTP, all of that can be achieved with both, or with a mix of both. So, what would drive you to one or the other? Well, for starters, the way you create them. A durable function is a code-first experience. You code it in C#, JavaScript, or another supported language. A Logic app, on the other hand, is a low or no code experience. You create your workflows in a graphical user interface. And that has its effects on connectivity. Connectivity-wise, this means that you have a bunch of bindings built in for functions, but there's much more connectors available out of the box for Logic apps. And then there's the things to orchestrate. In durable functions, you're orchestrating Azure Functions, which you write yourself, offering you a great amount of flexibility. In Logic apps, on the other hand, you'll typically work with previously made actions. Personally, I think Logic apps tend to offer a more reliable, faster way of getting your workflows or orchestrations up and running, while functions offer greater flexibility and enable reuse. More often than not, that brings me to combining both, just like we did in the demo. And with that, it's time for the section summary. In this section, we learn about Azure Logic Apps, a powerful tool for automating workflows and integrating various services. Imagine you need to automate sending an email to your team whenever a new payroll data file is uploaded, or synchronize data between your custom API and a CRM system. Logic apps handle these tasks with ease, and the best part is you can do it with little to no code using a visual designer on the Azure portal. Logic apps are part of Azure's serverless offerings, which means you get benefits like consumption-based pricing, no infrastructure management, and automatic scaling. depending on the hosting plan you choose, of course. The consumption plan offers true serverless benefits with automatic scaling and pay-as-you-go pricing. Other plans, like the Workflow Service Plan and App Service Environment V3 plan, offer more control and features, but are not consumption-based. The key components of Logic Apps are workflows, triggers, actions, and connectors. A workflow is a series of operations that define the task or process you want to automate. It always starts with one trigger, which is the event that initiates the workflow, such as an HTTP request or a new file in blob storage. Actions are the steps that follow the trigger, and connectors are used to integrate with other services. Testing and debugging Logic Apps is straightforward. You can view the trigger and run history on the portal to see what happened during each execution. You can also resubmit runs to test changes without having to wait for the trigger to fire again. We implemented a common scenario in which we integrated our Logic App with an Azure function. This is useful for tasks that require more complex processing than what can be achieved with built-in actions. Security is also a key consideration. It's always a key consideration, actually, for communication between Azure services, like the Logic App and a function. Managed identities are the way to go. Lastly, we compared Logic Apps with durable functions. Personally, I think Logic Apps tend to offer a more reliable, faster way of getting your workflows or orchestrations up and running, while functions offer greater flexibility and enable reuse. And just like is often the case in our sector, combining both is a common scenario.